Okay, so this is where we start kind of getting a question out of it. So what you have is you have a finite number of things on trial, so n trials, and in each case the probability of success is the same every time, and and the random variable is the number of successes from the n trials. And then the question is, what is the probability that x is equal to something is given by this formula, which is in the tables. Okay. Now, there's a way I can write this. Now, I'll probably use this notation here and there. You don't have to use it. So, to say that x number of successes from n trials, when the probability of success is p, you would write x. This symbol here means is distributed as B standing for binomial, n number of trials, P probability of success. So I'll probably use that notation just to signify that this is the situation. You have a number of trials, P is the probability of success, and X is the number of successes, and this is the formula for calculating this thing. So here is, say we had it already, I think we had the three good Chinese resistors, 2 bad ones. Say this, you're interested in, say, the probability that the number of good resistors is 3. You'd have to do the 0.8 by 0.8 by 0.8. That would be the 0.8 to the power of 3, and then the 0.2, the bad ones. And if there was 5 of them and 3 of them were good, how many were bad? 2. So this will give you the 2. And then how many different ways from 5 resistors can you pick 3 good ones? It's 5. Choose 3, which you get off your calculator. Okay. So we have a few examples here. So the first one, use the binomial distribution to find the probability that 1 or more out of 10 plants, 10 here is the things that are on trial. When the probability of death is 0.1. Now you can choose success to be a plant dying, that's perfectly okay. So if success is death, so P is equal to 0.1. So using the notation up above, where X is the number of deaths, we would have X is a binomial distribution. You have 10 things on trial, and the probability of success is 0.1. Sometimes I write BIN, B is okay. So we let X be the number of deaths, number of successes. Here success is defined as a death, probability of success is 0.1. We want to find the probability that you have 1 or more out of 10 die. Now there's a little bit of language in this. If you, some of them are going to be okay, this one is okay. If you're going to have 1 or more pints, how many pints are you going to have? 1 or 2 or 3 or 4 or 5 or 6 or 7. Now there's a max of 10, so it's 1 to 10. So without thinking too much, you could just say greater than or equal to 1 is 1 or 2 or 3 or 4 or 5 or 6 or 7 or 8 or 9 or 10. What does the or mean? Plus. You'd have to use that formula 10 times. Do you fancy that? No. So you don't want to do it that way. So how could you, what would be another way of doing it? No. So could you do it indirectly? Could you find the probability that you don't have 1 or more? What's not 1 or more?
Less than.
Which is? 0. So you could go off and find the probability that none of them die. So that's kind of set up here. So instead of saying that you've 1 or more, you can say that it's not 0. And if you wanted, you could just go ahead and calculate the probability of 0 of them dying and then take away 1, or else you could say the probability of not 0 is 1 minus probability of 0. And now we'll use the formula up there. So we're saying 1 or more is not 0, and probability of not something is 1 minus the probability of that something. And these are the things that we have a formula for in the tables. So you have equals to 1 minus. So I'm using this formula up here. What is the n here?
Number
10, number of things on trial. What is the k here? You should probably look at the up here.
K is defined in streets. No, number of the X is the number of successes. So is X equal to K, is it?
Yeah, x equal k. But in this particular example, what's k? 0. So you probably do x equal to k, probably do x equal to 0. So this is 10 choose 0. What's p here? So p is the probability of success, and we're saying here successes and dying.
0.
Was it? 0.1 to the power of k, which is 0. What's 1 minus p? 0.9. And what's n minus k? 10. So it'll be 0 of them dying, 10 of them living.
Is that the point between them and multiply?
Yeah. Yeah, they're all multiplied together. Might do a little, yeah, bracket's probably better actually, right? I won't put a bracket over here, it's a bit confusing. Now, you can put all these into the calculator, but the less you put into the calculator, the better. If you've a menu of 10 items, how many ways can you choose none? One. Pick none. So this is equal to 1. What's anything to the power of? Now, if you're unsure, you can just do your 10 choose 0. What's the power of 0 always equal to? 1. Now, if you're not sure, you can just put it into the calculator. So that's 1. I'm not going to put that in. I'm just going to put this in. So, and we're going to run with 4 significant figures, 0.6513. Now, you could have done that a slightly easier way. You could have not actually used the formula. You could have just said, well, 1 or more dying is not none of them dying. So I'll find the probability of none of them dying. And that would be, they'd all have to live. And if the probability of them dying is 0.1, what's the probability of them living? 0.9. So live and live and live and live. So it'd be 0.9 to the power of 10. And then take away from 1. Okay. See some more. Now I have BI here, that's the same as the B. So you got a manufacturer estimates that 5% of his output of a small item is defective, Chinese resistors, assuming a binomial distribution. Now, the question, if it says a sample of size 40, it doesn't have to say that, but some questions will say binomial distribution. Find the probability that a sample of 25, so you got 25 things on trial. Yeah. More than 2 would be defective. So you need, if it is binomial, you need n and p. If k will be, well, k2 is relevant. Not quite yet. What's the probability that you find a defective one? If you say finding a defective is a success. Say again? So we're saying 6. Now you can do the question in different ways, but I'm saying, say the thing you have here, this would be your success. The thing you're kind of counting. So finding a defective is success. So what's the probability of success? What's the probability of finding a defective? 5%, because 5% of them are. So you got here, P is equal to 0.05, that's 5%. And so if X is the number of defective items in the sample of 25, it's got a binomial distribution. N is 25, you've got 25 things on trial. Probability of success is 0.05. Now again, I'm going to use the notation, but if you give me the right answer, I won't care. Now, more than 2, if you're going to have more than 2 drinks, how many drinks is that? 3, 4, 5, 6, 7. So you're looking at here probability more than 2 is 3, 4, etc. up to 25. That's what more than 2 means. Now that is whatever 23 times using the formula. That's a disaster. So I'm going to flip it on its head. What is that not? 210. So not x equal to 0 or 1 or 2. So they're the same thing. X being 3, 4, 5, 6, 7, 8, 9, 10, or 25 is not 0 or 1 or 2. What's the probability of not something? One minus it, yeah. So this is 1 minus the probability that x is equal to 0 or 1 or 2. What does or mean? Plus. Now I'm going to run out a little space, so maybe I'll just do it here. So this is 1 minus, so this will be probability x equals, I'm just going to write 0, so that's probability x equal to 0 or 1 or 2. So or means at. You don't have to give me all this notation. I think it's, most people do better when they do, I think so, or just some version of it, some of it anyway. So 2 or more is 3 or 4 or 5 up to 25, which is not 0, 1 or 2. Probability of not something is 1 minus probability of something. That is probably x equal to 0 or 1 or 2. So we need to take 1 minus this, and or is mean add, so this is where we're at. And these are all like x equal to 0, x equal to 1, x equal to 2, using the formula, which I'll just write here. And just for this question, this is like the probability of k, probability x equal to k is n choose k, p to the power of k, 1 minus p to the power of n minus k. And as I said, it is in the tables. So, what have we got? So the first one, so using this formula, this is probability x equal to 0. And what's n? 25. Choose, what's k? 0. P, what's p? 0.05. What's k? What's k? You're right. 0, yeah. What's 1 minus p?
Negative 24. No, sorry.
0.95. What's n minus k? 25. So that's the first one. Plus the second one. What's n? 25. What's k? 1. P is the same. What is k? This is 0.95. What is n minus k? 24. Plus n is still 25. What's k now? 2. P is still 0.05. K now? 1 minus p is still the same. And n minus k? 23. You have to be careful with the bracket here. Now, say you didn't have the bracket and you got an answer out that was bigger than 1. I need you to do, or if you got a negative answer somehow. If you get an answer bigger than 1, or an answer small, a negative answer, what would you say about that?
Bigger than 1 or a negative answer?
Yeah.
So 100% or not?
No. So bigger than 1?
100%.
No. Bigger than 1.
More than
More than
1%.
As a probability, is that possible?
No.
No. Negative probability?
That's 0.
No. I'm saying negative.
0.
No, I'm saying negative.
It's not 0.
Well, it can't be. I thought a rate was 0 to 1.
It's between 0 and 1. So if you get an answer bigger than 1 or negative, you've gone wrong. And I want you to write